Hello guys, in this video I'll be talking about matrices. First of all, we will look at the definition of matrix and how we describe a matrix. Then we'll move on to addition and subtraction as well as multiplication of matrices, and in the end we will look at how to find the inverse of a matrix using two different methods. So let's begin by describing a matrix. Matrix represents another way of writing in information. So let's have a look at this example of this matrix 1, 0, 0, 1. This matrix here have two rows and two columns. So this is called a 2 by 2 matrix, and it's also known as a square matrix because the row equals to the column. And then to find the order of a matrix, all you do is to find 2 times 2, which in this case is 4. So the order of this matrix over here is 4. Now let's look at one more matrix, in which it looks like this: 4, 0, 6. Oops. I'm going to extend this bracket. 4, 0, 6. Right, and this one have a column 3 and then a row of 1. So this is called a 3 by 1 matrix. And this is order 3. 3 times 1 is 3. And this is called a column matrix because it only has one column. Alright, with that in mind, we can go and look at some addition and subtraction of matrices. Addition and subtraction of matrices are very simple. We're going to start with this example: 65, 3, 2, 10. This matrix plus, I don't know, I'm going to come up with something nice and easy to add: 1, 0, 4, 2. If I want to add this matrix, it's very simple. All you do is to add the corresponding ones. So first we do 1 plus 65, so 66. And then we have 2 plus 0, which gives us 2. And then 4 with 3, which is 7. And lastly 10 with 2, which is 12. And that's it. So with addition and subtraction, we simply just add the corresponding positions. Now let's have a look at the same subtraction. So let's see, we have -8, 6, 4, 1 minus -1, -1, -2, 0, and 3. Because we have many negative signs here, so we do need to be careful. -8 minus -1, that is -8 plus 1, so it's -7. And then 6 minus -2, so it's 6 plus 2, which gives us 8. And then 4 minus 0, which still is 4, and then 1 minus 3, which is -2. And this is our final answer. But bear in mind that when we are adding or subtracting matrices, we can only do addition or subtraction if they have the same dimensions. So only in this case it's a 2 by 2 with a 2 by 2. But let's say if we have a 2 by 3 matrix and a 2 by 2, these two cannot be added or subtracted together. Alright, now that's clear, so we can move on to multiplying matrices. Multiplication of matrices is not as straightforward as the ones with addition and subtraction, but it's still quite easy. There are two types of multiplication. One is by a scalar quantity. So what we meant by scalar quantity is just like 2 times 4, 3, 2, 4. This one is very easy because all you do is just 2 times 4, which is 8. And then I do 2 times 3, which is 6. And then 2 times 2 is 4. And then 2 times 4, which is 8. Just multiply the corresponding positions. But if I have multiplication of a matrix by another matrix, I have two matrices multiplied by together, it will be more complicated. Let's have a look at this example in which they have 6, 3, 2, 4 by 1, 3, 2, 1. Right, here in this example, what we do now is not multiplying the corresponding positions. So if we apply the logic that we had from previous questions, we would do 6 multiplied by 1, and then 3 multiplied by 3, and then 2 multiplied by 2, and then 4 multiplied by 1. And this will be incorrect because here you need to bear in mind when we do multiplication, all we do is just column by row. So I will multiply. Let me change the color. I will multiply this by this, and then this by this. So first of all, I do 6, 3 by 1, 2, right? So the upper row by the inner column. So 6 multiplied by 1, 6 multiplied by 1 here, plus 3 multiplied by 2, 3 multiplied by 2. And that's our first value. Then for our second value, we will have, let me put a bracket around it. Second value will be somewhere here, and that value would be this first row by the second column. So it's 6 multiplied by 3 plus 3 multiplied by 1. So this first value multiplied by this first, and then the second multiplied by the second, and we add it together. And then what we put here is this bottom row by this column here. So it's 2 with 1, 2 times 1, and then plus 4 times 3. Sorry, by 4 times 2. And then here, lastly, we will have the bottom row with the outer column. So we have 2 times 3 plus 4 times 1. Now our last step would be to simplify this matrix. 6 times 1 is 6, 6 plus 3 times 2, so it's 6 plus 6, which is just 12. And for the second part here, we will do 3 times 6 is 18. 18 plus 3 gives us 21. And then 2 times 1 is 2. 4 times 2 is 8, which is 10. And then 2 times 3 is 6. 6 plus 1 times 4, which is 4. So 6 plus 4 gives us 10. Our final matrix is 12, 21, 10, 10. Alright, that's it with the multiplication. Not all matrices can be multiplied together. And in order to recognize which two matrices can be multiplied together, all we do is that for matrix to be multiplied together, the number of columns in the first must be equal to the number of rows in the second. This can be seen clearly in the orders when the orders are considered. So, since multiplication is quite complicated, I'm going to take you through one more example with matrix multiplication. Let's say we want to multiply these two together. 1, 4, 2, 1, 3, 0. By 2, 2, 4, 4. I'm going to try to get some more colors. So first of all, we would do this by this. This is our first step. So let's go. 2 times 1 gives us 2. I'm going to write all of them out. 2 times 1, and then plus 4 times 4. 4 times 4. It makes sense because it's the first number multiplied by first number plus the second number multiplied by the second number. Alright, now this is the first number of our matrix, and the second number we would multiply. Still again, we have 1, 4 as our row, but our column will change now. We will get this column. So this column with still this row. So 1 times 2 plus 4 times 4. I'm going to put it in a bracket. Right, and then we will take a new row, which is this 2, 1, and then we take the inner column, which is this here, the inner one, 2, 4. And then again we do the corresponding numbers. 2 multiplied by 2 plus 4 multiplied by 1. And put it in a bracket. And then we still take this row, but now we change the column to be the outer column now. The yellow one, the outer column. So now it's the row 2, 1 with the column 2, 4. So the row 2, 1 is 2 times 2, and then plus 1 times 4. And then we have 2 more to go. Right, and that is the last row with the inner column now. So the last row is 3 times 2 plus 0 times 4. And lastly, we still have this row, this last row, but now we multiply it and add with the outer column. So that's 3 times 2 plus 0 times 4. Alright, and now comes the last step, simplification of this whole bunch of matrix. And that would give us 2 times 1 is 2, 2 plus 16 is 18. And then the second one is 1 times 2, 2, and then plus 16 is 18 again. And then 2 times 2 is 4, 4 plus 4 is 8. And then 2 times 2, which is 4, 4 plus 4 is 8 again. And then 3 times 2 is 6, 6 plus 0 is 6. And then the last one, we have 3 times 2 is 6, 6 plus 0 gives us 6 again. Alright, and that's our final answer. With that cleared out, we will now look at something called an identity matrix. And once we know the identity matrix, we can move on to inverse. Identity matrix is just this 2 by 2 square matrix. And then what's special about it is that when you multiply a matrix by its inverse, you will always get this identity matrix. So let's say if you're given a matrix and then it asks you to find the inverse of that matrix, all you do is this divided by that matrix. But since we do not know how to do division of matrix, so we're going to use a simultaneous equation. Now we'll understand this with an use of this example. If the question asks you to find the inverse of this matrix 6, 8, 2, 3, what you do is that you multiply it by another matrix, preferably 2 by 2 matrix again. So I'm going to let them be 4 unknowns, x, y, no, w, y, x, z. And then I will let it equal to this identity matrix that we looked at, which is 1, 0, 0, 1. Because we know when we try to find the inverse of a matrix, when we multiply that inverse by the original matrix, we will get the identity matrix. So now we're going to use the first method, which is using simultaneous equation. Now referring back to what we did with the multiplication of matrix, we said we would multiply this row by this column first for our first value. So we're going to do that. 6 multiplied by w is 6w, and then 8 multiplied by x, which is 8x, and I'm going to add these two. 8x. And that's my first value. Here, I'm going to put it in brackets. For my second value, I will still take the first row, but now with the second column. Right, and that will give me 6 multiplied by y, 6y, plus 8 multiplied by z, 8z. Alright, and that is my second value. Now moving on, I will get the second row with this first column, which is 2 times w plus 3 times x. And our last step is to take the last column here, the last row with the last column, with the outer column, you can also call. So it will be 2y plus 3 multiplied by z, 3z. Right, and this one is a big matrix again. All we need to do now is to simplify this. So I'm going to write it below. You will see that there are 4 numbers. There are 4 algebraic expressions, you can also call, and the corresponding ones will equal to the identity matrix. So this first one would equal to 1, the second one will equal to 0, the third one will equal to 0, the fourth one is 1. So I'm gonna write that out here in this space I have. 6w plus 8x equals to 1. And then I'm gonna write the second one over here, 2w plus 3x equals to 0. And then I need to write 2 more, which is 6y plus 8z equals to 0. And lastly, we have 2y plus 3z equals to 1. Now many of you can already see where I'm going, and then to find w, x, y, z would be very easy because now we have two sets of simultaneous equations. If you know how to solve simultaneous equations, this one will be really easy. For the first method, for the first simultaneous equation, the first one here, the light pink one, what we do is most simply we can do substitution, which is hard. We're going to do elimination method, which we're going to multiply this second equation here. I'm going to multiply this by 2, so I can eliminate the w. So by 3, so I can eliminate the w. So I'll get 6w plus 3 times 3x, 9x equals to 0. And then I'm going to copy down the first equation over here. 6w plus 8x equals to 1. And that will be very easy. We will get that negative x equals to 1. And finally, x equals to negative 1. And once we know x equals to negative 1, we can substitute it back into any of these two original equations. And then we will get w will equal to 1.5. Alright, and same with the other two. We're going to solve this again by elimination, which I think will be easier. I will multiply the second one by 3 again. So get 6y plus 3 times 3z, which is 9z, equals to 3. And I'm going to copy down the first equation, 6y plus 8z equals to 0. I'm going to eliminate the y now. I'm going to do subtraction of the first equation. 6y minus 6y is 0, 9z minus 8z is just z, and then 3 minus 0 will be 3. So z equals to 3, and if you substitute it back into any of these two equations, you will get that y equals to negative 4. And that's that. We found the value of x, w, y, and z. We can now substitute it back in. So the inverse of 6823 is 1.5 for negative 4, negative 1, and 3. Yeah, we just substituted in the values that we found back into this 4 unknowns that we set before. And now that's done, I'm going to show you one more method of finding the inverse of a matrix. But if you prefer the first simultaneous equation method, then you can go with that. But the second method will be slightly easier, but you would need to remember a formula. So if A equals to the matrix W, Y, X, Z, I'm going to use the unknowns like the one that I used, then the inverse of A would equal to 1 over WZ minus XY times the matrix Z, the negative Y, negative X, and W. All you do is to substitute in the corresponding values. So if it's given, let's use this example, the same example as the one above, 6, 8, 2, 3. Let's check if we get the same answer. All you do here is to substitute in W for 6, Y for 8, X for 2, and Z for 3 into this whole bunch of things, and then multiply these to this matrix by the scalar, and then you will end up with a final matrix. So let's do that. 1 over WZ. And if you go back to this original matrix, you get that WZ and XY, they're actually cross multiplication. So all you do is that W multiplied by Z minus X multiplied by Y. And this is quite easy to remember as well. So 6 multiplied by 3 minus 2 multiplied by 8. So that would be 18 multiplied by 16. So it would be just 1 over 2. Right. And then I'm going to multiply this by this matrix, which when you go look carefully at it, it's just W and Z changed position. Before W was in the place of Z, and then Z was in place of W. So you can remember this as being these two changing positions, and these two, the other two here, they did not change position, but instead they changed signs. So if originally Y is positive, it will become negative. If it's negative, it will become positive, and it's the same for X. So I'm going to do that right now. In the place of 6, I'm going to put 3, and in place of 3, I'm going to put 6. And then for 2 and 8, they stay in their position, but they change sign. Positive 2 change to negative 2. Positive 8 change to negative 8. Really be careful if these two numbers are negative. Don't put the signs wrong. And then you just multiply these two. A half multiplied by 3 would be 1.5. And then a half multiplied by negative 8 will get negative 4. A half multiplied by negative 2, we will get negative 1. A half multiplied by 6, we get 3. And that's our final answer, and this is exactly the same as we found with the simultaneous equation method. Alright, and that brings us to the end of this video, and it's basically everything you need to know regarding matrices in your IGCSE exam.